Today we are going to cover 14BB, which is standard form to slope intercept form. Our content objective is students will be able to write linear equations from standard form to slope intercept form. Our language objective is students will be able to verbally justify their steps. Why am I learning this? Well, it's important for graphing linear equations. So first, let's go over some background knowledge. We did learn two different forms of linear equations. The first one is slope-intercept form, which looks like this: y equals mx plus b, where m is your slope and b is your y-intercept. The one we learned from the previous lesson is standard form. Standard form looks like the following: ax plus by equals c, where a, b, and c are integers, which means they're not fractions, nor are they decimals. Some other background knowledge that I want to go over is how to solve for certain variables. So in this case, we've done this when we were going over equations. In this case, I'm going to distribute first, move my variable over to the left. And so notice here, in order to move my variable over to the left, I have to do the opposite. Here, in order to isolate my x, I'm going to have to do the opposite and subtract 20 from both sides, leaving me with negative 8x equals negative 32. Please, just a friendly reminder, negative 8x means negative 8 times x. So the inverse would be to divide both sides by 8, negative 8 that is, leaving me with x equals 4, because here the negatives cancel each other out. So hopefully that looks familiar. One more background knowledge that we want to go over is slope-intercept form. Just a friendly reminder, m is your slope and b is your y-intercept. So in a problem like this is your y-intercept, so you're going to plot that first on your graph, and then you will use your slope to graph. So here you're going to go rise 2, run 3, rise 2, run 3. If you run out of space, you can always go backwards, so go down 2, left 3, down 2, left 3, and there is your line. So hopefully that's a quick refresher and you now have totally remembered how to graph using slope-intercept form. Okay, so now is moving on to the very first official problem. We're going to be asked to write the slope-intercept form of the equation of the line. So right now, this is currently in what we call standard form. So if you remember, that's basically ax plus by equals c. So first things first, since I am trying to get into slope-intercept form, just a friendly reminder, that's y equals mx plus b. So essentially, I'm trying to solve for y. I'm trying to isolate y. So I'm going to go ahead and circle y, because that's what I'm trying to isolate. I need to get rid of everything else. So here, in order to get rid of 2x, I'm going to subtract 2x from both sides, which would leave me with y equals, well, let's see. What should I write first? Should I write the 8 or should I write the negative 2x? If you go back to slope-intercept form, notice your coefficient with the variable is normally written first. So I would write this as y equals negative 2x plus 8. So now this is my equation in slope-intercept form. Here's my slope, here's my y-intercept. So something that you want to be very careful about is as you're rewriting things, you want to make sure the variable goes first before your constant. Okay, so easy enough. Let's go ahead and try another example. For number 2, we're going to write it in slope-intercept form, given this equation here. Currently, it's in standard form, so that's basically ax plus by equals c. Just a friendly reminder, slope-intercept form is y equals mx plus b. So essentially, I'm trying to isolate the y. So in this equation here, I'm going to go ahead and circle y, because that's what I'm trying to isolate. I'm going to go ahead and get rid of everything else. So in this case, I need to get rid of the minus 5x. So I'm going to do the inverse, which is to add 5x to both sides. This is going to cancel out, leaving me with y equals, again, the variable should come first because that's how the form is normally written. So I'm going to write that as y equals 5x plus 10. Now this is what we would call slope-intercept form, where 5 is my slope and 10 is my y-intercept. So now what I'm going to go ahead and have you do is pause the video and try to do number 3 on your own. Go ahead and convert that equation into slope-intercept form. Okay, so let's see how well we did. So first things first, recognize that this is in standard form. It's not already in slope-intercept form. I want to get into the form of y equals mx plus b, so I want to get it to where y is isolated. So first I'm going to go ahead and circle y. Okay, so as of right now, I'm going to go ahead and get rid of the 6x by subtracting 6x from both sides, which is now going to leave me with 3y equals negative 6x plus 12. Once again, I'm putting the variable first because that's how the form is normally written. Now notice I'm not done just yet. I still need to get rid of this 3. This 3y technically means 3 times y, so the inverse of multiplying by 3 would be to divide by 3. So I'm going to divide both sides by 3. So here, notice the 3's are going to cancel out. Now what's going to happen is this, because what does this all mean? Well, it technically means y equals negative 6x over 3 plus 12 over 3 as well. So notice when the entire expression is divided by 3, each term is divided by 3. So this is going to leave me with y equals negative 2x plus 4. How did I get that? Negative 6 divided by 3 is negative 2, and 12 divided by 3 is 4. So now this is my equation in slope-intercept form, where negative 2 is the slope and 4 is my y-intercept. So the only thing different about this particular problem in comparison to the last one is there was that one last step of getting rid of the coefficient in front of your y variable. Okay, so now, moving on. Let's try number 4 together. Again, we currently have it in standard form, so it's not already in slope-intercept form. I'm going to go ahead and work on isolating y to get in the form of y equals mx plus b. So first things first, I'm going to go ahead and circle the y and recognize that I first need to get rid of the negative 2x. I'm going to do that by doing the inverse, which is to add 2x to both sides, leaving me with 5y equals 2x plus 15. Once again, you want to write your variable first because that's the way slope-intercept form is normally written. Okay, so now the only thing that I need to do is isolate y. So how do I do that? Well, first I have to recognize that 5y means 5 times y. So I'm going to have to do the inverse and divide both sides by 5. So here the 5's will cancel each other out, leaving me with this expression here. So again, I need to figure out what this all means. When this entire expression is being divided by 5, it means each term is divided by 5. So I'm going to write it as y equals 2x over 5 plus 15, also divided by 5. So all I need to do now is simplify this, and that's going to leave me with y equals 2/5 x plus 3. So here 2/5 can be reduced, but 15/5 can be reduced to 3. So that's going to be my slope-intercept form, where 2/5 is my slope and 3 is my y-intercept. Okay, so now at this point I'm going to go ahead and have you pause the video and try this one on your own. Okay, so let's see how well we did. First things first, I got to recognize that it is in that it's in standard form, so it's not yet in slope-intercept form. I need to get into slope-intercept form by getting it into y equals mx plus b, so I must isolate y. First things first, I'm going to get rid of this x by doing the inverse, which is to subtract x from both sides, leaving me with negative 3y equals negative x plus 8. Last but not least, I need to get rid of this coefficient. This negative 3y means negative 3 times y. So the inverse of multiplying would be to divide both sides by a negative 3. The negative 3's will cancel each other out, leaving me with y equals negative x over negative 3 plus 8 over negative 3. So now I'm going to recognize that the negatives cancel each other out here, and the final expression will be y equals 1/3 x minus 8/3. So first of all, if you're wondering how I came up with 1/3, if you want to, you can write a 1 in front of this x and recognize that the fraction is 1/3. And also, if you're wondering how I got minus 8/3, it's because a positive times a negative is a negative. So here, let's go back. My slope is 1/3, and my y-intercept is at -8/3. So I know it's a fraction, but it is possible for a graph to intersect the y-axis at a number that's not a whole number. So keep that in mind. Okay, so moving on to number 6. Go ahead and pause the video once more and try this one on your own. Okay, so first things first, I need to isolate y, so I'm going to go ahead and circle y. Next thing I'm going to do is get rid of this minus 4x by doing the inverse, which is to add 4x to both sides, leaving me with negative 5y equals 4x plus 3. Last but not least, I need to get rid of this negative 5. This means negative 5 times y, so the inverse would be to divide both sides by negative 5, leaving me with y equals 4x over negative 5 plus 3 over negative 5. So here, positive 4 divided by negative 5 would be negative. So that's going to be a negative 4/5 x. And a positive times a negative would be a negative, and that's how we end up with negative 3/5. So here, negative 4/5 is my slope, and negative 3/5 is my y-intercept. And there you have it. So now what we're going to do is we're going to look at this equation here, and we're going to decide what we want to do. Okay, you have a choice. You can use slope-intercept form, or you can go ahead and use x-intercepts and y-intercepts to graph this. So first thing that I'm going to do is I'm going to do exactly what we just learned. I'm going to convert this into slope-intercept form and graph it that way. So I'm going to isolate y by going ahead and getting rid of x, and the way that I do it is to do the inverse. So I'm going to add x to both sides, leaving me with 2y equals x plus 4. Now what I need to do is get rid of the coefficients, so I must divide both sides by 2. So this is going to leave me with y equals, just to make things a little bit easier when I see the fraction, I'm going to go ahead and call that a 1x over 2 plus 4 also divided by 2, which would reduce this to y equals 1/2 x plus 2. So obviously you saw that I put a 1 here, so you can recognize that that is a 1/2. So now that I have the slope and the y-intercept, I can go ahead and graph it. The y-intercept occurs at 2, so I'm going to go ahead and look on the y-axis and graph my point at 2. Then I'm going to use my slope, which is 1/2, and graph. It's going to go up 1 over 2, up 1 over 2, whoops, up 1 over 2, and then I can also go backwards. I can go down 1 to the left 2, down 1 to the left 2, down 1 to the left 2, and simply draw your line from there. So notice I can do that. I can go ahead and convert this equation to slope-intercept form, or I can go ahead and learn use what I learned yesterday. I can use x and y-intercepts to graph. So here, if I wanted to find the x-intercept, I'm going to go ahead and set y equal to 0. Once I do that, I'm going to solve, and I'm going to get negative x equals 4. I can't leave it at that. I want to know what x is, not what negative x is. So here, I'm going to divide both sides by negative 1. I'm going to be left with x equals negative 4. So my x-intercept occurs at negative 4. So on my x-axis, I'm going to go ahead and put my point at negative 4. So in this ordered pair would be negative 4, 0, because ordered pairs are written as x, y. Here's your x, here's your y. Now for the y-intercept, I'm going to need to set x equal to 0. So I'm going to go ahead and do that and plug it into my equation. I'm going to solve. I'm going to need 2y equals 4, so y equals 2. So my y-intercept occurs at 2, so I'm on the y-axis. I'm going to go ahead and plot my point at 2. My ordered pair should be written as x, y, so it should be 0, 2. Then all you need to do is graph your 2 points and draw your line. Now something that I want you to still practice and recognize is, what's the slope of this line? Well, the rise is 1, 2. And the run is 1, 2, 3, 4, which reduces to 1/2. Okay, so in the previous example, you saw the slope was 1/2, but If you're choosing to use x and y intercepts to graph, you won't see it, but you can still determine the slope based off of your graph. Okay. So now what I'm going to do is go ahead and do one more example with you. I'm going to have you try the next two on your own. So again, the very first one that I'm going to show you is doing in slope-intercept form. Again, for you on your homework, you're going to get to decide if you want to turn things into slope-intercept form or if you want to go ahead and plot the x-intercept and the y-intercept. It's totally up to you, whatever is easiest. So in order to turn this into slope-intercept form, I need to isolate y. So first things first, I need to get rid of this negative 3x by adding 3x to both sides, leaving me with the negative 2y equals 3x plus 4. Now I need to get rid of this coefficient in front of the y, so negative 2y means negative 2 times y. So I'm going to do the inverse and divide everything by negative 2. So here the negative 2's cancel each other out, just leaving me with y equals 3x over negative 2 plus 4 over negative 2. This is going to reduce to y equals negative 3 halves x minus 2. Here is my slope and here is my y-intercept. So when I graph using slope-intercept form, I'm going to definitely start with the y-intercept. It's occurring at negative 2, so on my y-axis, I'm going to go ahead and plot my point at negative 2. Then I'm going to use my slope to see where this graph is headed. So since it's a negative 3 halves, I'm going to go down 1, 2, 3 and over 1, 2. And then I can also go the opposite direction and go up 3 and to the left 2. I like to go until I have no more space. That way I know my graph is pretty accurate. And there you have it. You have your line. So obviously here you can tell what the slope is. It's negative 3 halves. Okay, now let's go ahead and try the other method, which is to use the x and y intercept. So for the x-intercept, I'm going to have to set y equal to 0. So I'm going to go ahead and do that. I'm going to solve, and I'm going to end up with x equals negative 4/3. So right now, it's not that favorable, but is it wrong? No, absolutely not. Here, the x-intercept occurs at negative 4/3. I'm going to have to convert that into a decimal so that I can get a better idea of where that's going to fall on my x-axis. So for side work, I'm going to do 4 divided by 3. That goes in once. The remainder of 1, let's go ahead and bring down a 0. It's going to go about 3 times. And really, this is enough. Okay, 1 3/10, because that's all I need to know. I can place a point on the graph right now. On the x-axis, it's going to be placed at negative 1 3/10, which is about here. So do you really have to divide it all the way out? No, you just need enough so you can figure out where the point should go on your graph. So that is going to be written as negative 4/3 comma 0. Why? Because it's always written as x comma y. Now for my y-intercept, you're going to again set x equal to 0. You're going to solve, and here I'm going to get y equals negative 2. So on my y-axis, I'm going to go ahead and place my point at negative 2. This ordered pair would be written as 0, comma, negative 2. So now that I have the 2 points on my graph, I'm just going to go ahead and draw a line, and there you have it. Now, if I were to ask you what the slope is, a lot of students are going to have the tendency to try to only use the 2 ordered pairs that were given from the x-intercept. Do you have to use these 2? No. And would you want to? No, because it's hard to tell the slope using a negative 4/3, right? So I'm going to go ahead and pick 2 nice ordered pairs. I would choose this point right here as well as this point right here. And I can still find the slope. The slope is a negative 1, 2, 3 over 1, 2. So it's still a slope of negative 3 halves. Notice that's the same exact slope from the previous one. So again, they should match because it just shouldn't matter which method you use. You should end up with the same exact answer. Okay, so now go ahead and pause the video and try number 9 on your own. Okay, so whichever method you chose to do, okay, I'm going to quickly go over both methods Just remember, you're going to have the same result for graph, no matter which method you use. Here, if you use slope-intercept form, you're going to isolate y by subtracting 2x from both sides. Here, you need to divide both sides by 8, which is going to leave you with y here. First of all, the 8's cancel each other out. Y equals negative 2x over 8 plus 7 also over 8, which reduces to y equals negative 1/4 x plus 7/8. Now, is this a nice one to use to graph? I would definitely say no, because I'm going to have to plot 7/8 as my y-intercept, which I would say is, let's see, 7/8. If you divide it, that's going to be about, let's say, 8/10. So on the y-axis, I'm going to find where I think 8/10 is, which I'm going to say is about right there. And then from there, I'm going to have to use my slope, which is a negative 1/4. So here, if I'm originally, sorry, it's a negative 1/4. So if I'm originally at a 8/10, if I go down, it's going to be about here, and then I have to go over 4. So is this the best method to use? Absolutely not. So again, I'm going to continue go about 1 and then over 4, which is going to be right here. And I can go the opposite direction, so up 1 over 4, and that's about all that I can do. Okay. So here, could I still find the slope? Yes, if I can manage to find two nice ordered pairs, I can. But let's see, can I find two nice ordered pairs? I can't, so I'm not going to try to find the slope. We're just using this to practice to find slope. Do you always need to on your homework? For the most part, no. Okay, so let's go ahead and move on to number 10, the other method. You can go ahead and plot using the x and y intercepts. Here you set the y to equal to 0 so you can find the x-intercept, and you should end up with y. The x-intercept occurs at 7/2. So again, to figure that out, I'm going to divide 7 divided by 2, which is going to go about 3.5. So on the x-axis, I'm going to go ahead and plot my point at 3.5. Now for my y-intercept, I'm going to do the same. I'm going to put x for 0, 0 for x. Solve, and in this case I'm going to get y equals 7/8. So again, you're going to divide, and hopefully you remember from the previous one, 7/8 is about 8/10. So on the y-axis, I'm going to plot where I think 8/10 is, and then simply draw a line. Again, I'm not asking you to find slope. It's just an extra exercise for you so that you can practice finding slope in any situation, whether it's in slope-intercept form or standard form. Okay, so now moving on to the very last example. The last one has something slightly different than before. So in this case, you have 15 equals negative 10x minus 5y. In this case, it's different. Why? Because y was normally on the left side, but now it's on the right side. So what am I going to do? Well, to make things easier for myself, I'm just going to rewrite it so that the y is on the left side. So I'm going to flip-flop the equation to say negative 10x minus 5y equals 15. At this point, I'm going to go ahead and solve like I normally do. I'm going to isolate y by adding 10 to both sides first. I'm going to be left with negative 5y equals 10x plus 15. Then I have to get rid of my coefficient by dividing both sides by negative 5, which would leave me with y equals 10x over negative 5 plus 15 over negative 5. So here all I need to do is reduce, and I'm going to end up with y equals negative 2x minus 3. This is in slope-intercept form, so I'm going to say the y-intercept is at negative 3. And my slope, since it's written as a whole number, I'm going to write it as a fraction by putting it over 1. So here it's going to go down 2 over 1, down 2 over 1. I can also go in the opposite direction. And you know me, I like to go as far as I can until I fall off the graph, because this ensures that I'm as accurate as I possibly can be. And there you have it. So here, obviously, you know what the slope is, so I don't even have to try to find it. But let's go ahead and try the other method, which was to use the x and y intercepts. If I want the x-intercept, I have to set y equal to 0, so I'm going to go ahead and do that. Solve, and I'm going to end up with x equals -3/2. So hopefully, looking at this example, you might have noticed maybe using slope-intercept form was a better idea. But is it impossible to put your x-intercept at -3/2? Absolutely not. Both methods will work. One might be a little bit easier for you though. So here, I'm going to go ahead and divide this out so I can get an idea of where this is going to be. Oops, I did that wrong. Let's try that again. 2 goes in 3 one time with a remainder of 1. Bring down your decimal 0. It's going to go -1.5. So on my x-axis, I'm going to go ahead and plot -1.5 as my x-intercept. Now for my y-intercept, I'm going to go ahead and set x equal to 0. Solve. Now I'm going to get that the y-intercept occurs at -3. So I'm going to go ahead and plot that point at -3. And there you go. You have your graph. So once again, you can still find your slope. You might not want to use the two x and y-intercepts because you have a fraction here. So all you need to do is find some nice ordered pair. This one's a nice ordered pair. Choose this instead. And what else is a nice ordered pair? See, so is this one. So here, just count. It's going down 1, 2, 3, 4, 5, 6. So it's -6 as it went down. And then it's going to the right 1, 2, 3. So my slope is a -2. And that's all there is to it. So that's going to actually conclude our lesson for today. As always, thank you so much for tuning in. And until next time, bye.